You are now tuned in to the network, the YouTube channel that takes complex networking topics and dumbs them down to a more simpler language. Today's topic is configure and verify tracking objects, specifically the subsection 6.10b of the CCNP route exam, and that is tracking different entities. For example, interfaces and IPSLA results is a topic in the CCNP route exam. It'll be known as CCNP Enterprise Exam come February 24th, 2020. Let's go ahead and take a look at the exam blueprint and see where we came from and where we're headed. Hashtag labeveryday. Also, before you leave this video, make sure you hit that like button, make sure you hit that subscribe button, and hit that notification bell to let you know when I upload these videos. All right, this exam blueprint implementing Cisco IP routing, exam code 300-101. It'll be 300-401 once the new exam comes out. And we are on the last two sections here. These two sections right here, we just finished tracking objects, 6.10a, tracking objects. We are going to do today 6.10b, tracking different entities. After that, we are going to do configure and verify Cisco NetFlow. We'll do this as one whole video and finally wrap up this series. And then I will, I know I have a couple videos that are missing, so I might just plug those in. Just make sure you hit that notification bell and you'll know when those other ones are coming up. We pretty much wrapped up this video series. What are tracking objects? Well, we discussed that in the last video. I'll explain it again. You know, it's similar to how SNMP works, right? When something goes down or there's the state of an object or the state of something like any networking device, but it don't necessarily have to be something physical like or even virtual like an interface or loopback or something like that. If there's something that changes, if we're tracking that object, we can set it to do something else, take action. Like, for example, if we have a static route, like we did this in the last video in the GNS3 lab, if we have a static route pointing somewhere, right? If the interface that the static route points to goes down, we can set it to take action. Okay, if this interface goes down, go this way or do this. You know, we can do, it's so flexible. We can say, if this DNS server, if we have a specific object, this DNS server, if this DNS server goes down, do this, you know, take some other action. And that's what tracking objects do. We track different objects, and an object can be, for example, as you see right here, interfaces, an IPSLA result. You know what IPSLA is, right? It's like a service level agreement. If something is not being met, if service level is not being met, then take action. So, for example, if we're experiencing packet loss of more than 10%, then start taking this route so that way we can get somewhere. It's just so flexible. There's so many things you can do. Obviously, we're not going to cover them all because then this video will be like 3 hours long. So for the specific purpose of this video, we are just going to do a lab on tracking. I believe we're going to be tracking a static route and the reachability of a telnet server. Or a telnet to a specific server. Let's go ahead and take a look at the official definition of tracking objects. So this is mostly going to be a recap of last video, and plus we're going to combine it with a little bit of policy-based routing. If you remember what that was, we did a video on that in section 3.12, configure and verify policy-based routing. So we're going to touch a little bit on that today as well. Object tracking allows you to track specific objects on the device, such as the interface line protocol state, IP routing, and route reachability, and to take action when a tracked object's state changes. So this is just, I sound like a broken record right now, don't I? This is exactly what I said in the last video. It's just that you don't have to necessarily just track there's so many things you can track. You know, this feature allows you to increase the availability of the network and shorten recovery time if an object state goes down. So like in this example right here, we could have a static route pointing to our primary link, right? This could be our ISP. If this interface goes down, we can set it so that way when this interface goes down. Or if we lose this static route, or if this interface goes down, whatever, we can track so many things that lets us know, okay, if this link goes down, we can set it to point this way, right? Obviously, you can do this with redundancy protocols such as HSRP or VRRP, right? But this is just another way of doing it, tracking objects. Like we said, we can increase the availability of the network, and that's what service level agreement does. We increase the availability of a network, right? Here is some basic tracking commands. The command for tracking interface is simply put, track, and then you do an object number, and then whatever you want to track. In this case, we're tracking the interface. You can track the line protocol if it's down, or IP routing, whatever. You can configure it to track a static route by just typing out the static route statement, right? And then what to do with it, right? You can do the interface, the next hop, right? Like say this is the static route, take the next hop of this or the interface of that and apply the track object to this. So with this, we're going to say this is track object 1, 2, or 3 or whatever. So let's say track object 1 says to test the IP routing. Let's say we could say if we lose this route, take action. And that's what we're doing here. We could also combine it with PBR. Again, policy-based routing. If you don't know what that is, look at that video on what I just mentioned, the aforementioned topic. You can also configure PBR to work with track objects. We're going to do a little bit of that today in GNS3. Or not GNS3, I'm sorry, Boston NetSim. Shout out to Boston NetSim. In this case, if the object is up, PBR works as configured. If the object is down, PBR works as if the set command does not exist, meaning the router will route the traffic per normal destination-based routing. So in other words, the default routing action. So if the policy-based routing says to do this, if we lose that policy, then take the default action of what the routing table says. So you do show IP route, do this. That's what it's saying here. Here's the command for PBR with a track object. We know how to do PBR. If you don't, again, look at that video. Set, remember we do a set and a match, right? The set says set the IP, next hop. This part right here is the track object, right? The state of it, right? And then what to do with it. You can put a sequence number, and then the track object is how you tie it together. You do track, and then let's say the track object is track 1 or 2 or 5 or whatever, you put the number there. Again, we're going to do that in Boston NetSim. Y'all know what it is when y'all see this little girl. So let's go ahead and fire up Boston NetSim and play with an actual route lab. Yes, in Boston NetSim. All right, so here's the lab we're going to be working with today. In this lab, you'll configure route maps to organize traffic from the LAN connected to router 3 to resources running on router 1. In addition to organizing traffic, you will use IP service level agreements and object tracking to configure router 3 to automatically verify the connectivity with a neighboring IP address. All passwords in this lab is boson, right? And here's another look of the topology. What we're going to do is we're going to have traffic going to router 1, right? But router 3, this little area network right here, right? Traffic normally goes to router 1 going through router 2 and then to router 1 like that. We're going to create a route map or policy-based routing so that way it tests, well actually IPSLA will test the connectivity of this interface right here. If it goes down, we're going to have it go this way instead of that way. So we're going to basically combine IPSLA with policy-based routing, right? So let's go ahead and take a look at that right here, right? Again, he would normally take this way to get to router 1, but we're going to test connectivity to the serial interface here and then have it go this way instead, right? With policy-based routing. We're going to do telnet traffic. Here is some basic commands right here. Here goes route maps. We've discussed all that again. We're going to do it again. Here's some show commands. Here's a little bit more show commands if you want to pause it, freeze frame it. Obviously, we know how to telnet. Here's the basic IP addressing guide. All right, so step 1, verify connectivity with the LAN. In this task, you will configure router 3, which is this guy right here, to use IPSLA to monitor connectivity with an interface on the LAN device. All configuration steps in this task will be performed on router 3 unless otherwise specified. Create an IPSLA with an operation ID of 1. So we're going to go to enable config mode or enable mode, and then go to global config mode. And we're going to say IPSLA. Remember, in the other SLA videos, we were doing IPSLA monitor and then a number with the operation ID, which is 1. But with this version of iOS, remember, this is a simulator. There's different iOS versions I've noticed throughout my studies that you could do IPSLA and then a number, or IPSLA monitor and then a number. And that's what GNS3 I had to do. But in this, I noticed that you have to do IPSLA 1. I wish I explained that when I saw that, but I was like, something's wrong here. But yeah, there's 2 ways to start create an IPSLA operation. So in this case, it's IPSLA 1. Then you're going to be in IPSLA config mode. Step 2 says configure IPSLA to test connectivity to router 1's serial 00 interface, which is located here. 10.10.10.1, the test should be performed by using ICMP packets, or ping, with a source of router 3's Ethernet 0.1 interface, which is located right here. So let's go ahead and do that. How do we do that? If you notice here, context-sensitive help says we can get out of IPSLA config mode, or we can do ICMP echo, which is basically ping packets. And that's what we're going to do here, ICMP echo. The destination address was router 1's serial 00 interface, which is 10.10.10.1. What else they want here? The source interface, which was source-interface, which is Ethernet 0/1. Right? Now we are in IPSLA echo config mode. Step 3, configure IPSLA 1 to perform the test against router 1's serial 00 interface at 90-second intervals, right? We learned this from the IPSLA video. That was frequency was the keyword, 90. That's basically a minute and a half, right? That's it right there. Step 4, display a summary of IPSLAs that are configured on the router. Is IPSLA active? What statistics and return code are displayed? So let's get out of this here and do a, we know it's going to be a show command, show IPSLA. What options we have here? We can do configuration, statistics, or summary. He said he wanted a summary. So I'm going to do summary. And he asked, is it active? Well, if we look at the codes here, we have active is star. Inactive is this sign right here. That's y'all pop quiz for today. What is the official name for this symbol right here? If you know the answer to that, put it in the comments below. Inactive, that means inactive. And then this symbol right here means pending. Well, if you look at here, operation ID means that symbol right there. If you know the answer to that, please put in the comments. Means it's inactive. And what return code is displayed? Well, we see the return code right here says it's unknown. Last run 5 minutes and 2 seconds ago. I've been blabbing away to y'all ear right here. Step 5 says display detailed information about the IPSLA configuration on the router. So we know that's a show command. When you show IPSLA, he said detailed, so it's just configuration, right? In actual iOS, Cisco iOS, you actually got to put the operation ID number. So in this case, it'll be show IPSLA configuration and then 1, 2, 3, or whatever number you created. Obviously, this is a simulator. We don't even need to put that on here. So as per the context sensitive help here, you do a question mark, you see it's a carriage return right there. Hit enter, and let me widen this up so y'all can see. You go to the top, and what were the questions he said? He said, what do you notice about the scheduling configuration? Well, we go to the top, that's where the schedule information is, right? Right here. We have here, it says frequency is 90 seconds. That's what we said we wanted, not considered if randomly scheduled. The start time is pending trigger. We didn't create a start time, right? Remember we did that. Remember in the last video, we created a start time and all that. And I put those little cutscenes of the outcast and all that. We did. There's no group schedule, no random. It's not randomly scheduled. Life is 3,600 seconds, which I believe is an hour, if I'm not mistaken. 3,600 seconds. Entry age out is never. All of this stuff is default, so don't worry about that. That's all we have under the schedule here. Those are all default. Step 6 says schedule IPSLA to execute forever, starting immediately. So we got to go to global config mode again. We know we need to do IPSLA 1, he said. No, we don't want to do that. We just do IPSLA schedule. Cisco iOS will give you way more options than this, right? So we know we want to configure the scheduling here. We do schedule. Now we put the actual entry number, which is 1. And as you see here, our options here is the life or the start time. You can start with either or. I remember last time I think we started with the start time. So let's go ahead and do the start time. What time did he say we wanted to start? He said starting immediately, which is we do start time. He said now. That's our only options here. Again, in Cisco iOS, you're going to get way more options than this. He said, when does he want it? Execute forever. Yeah, I remember my little cutscenes. Oh, and shout out to, I don't remember the subscriber, but he said, man, he liked, it was just one of my favorite comments. He just liked my teaching style. He liked the cutscenes that I put in there. Y'all know I do this stuff to keep y'all awake because some of this stuff can be really boring. And, sometimes I have my little corny jokes and stuff like that. But, you'll see in the last video is a perfect example of that. And he said start time is now, life is forever. Carriage return there, so we just click enter. And now we've got us the schedule, right? We display detailed information about the configuration. Again, what do we notice about the scheduling now? So we get out of this, go to privileged exec mode to do show IP SLA schedule, no, show IP SLA configuration. And we look at the schedule and you see here, the frequency is 90 seconds. Next start time has already passed because we said now at that time, right? Group schedule false, and random schedule false. We didn't change that. Lifetime was forever ever. Entry age out, we didn't set that up. All of this stuff is default, so we didn't touch any of this other stuff. Perfect. So that's what the scheduling says now. Display a summary. What does it say? We go to summary, so IPSLA summary, and the summary says, the question says, is IPSLA active now? And if you notice, the code says the asterisk means active, so yes, operation ID SLA1 is active now. What's the other question? What statistics and return code are displayed? Well, the statistic says round trip time is 23, I believe that's milliseconds. Yeah, milliseconds. Return code is okay. So our operation for IPSLA is active now. It's working. Display statistics configured on the router. What do you notice about the start time? Oh, we said that already. Oh, we didn't do. Now we got to do statistics. Show IPSLA statistics. Now he says, what do we notice about the start time? Start time says then. I know it says 1993, but we didn't change the clock on here, so that was back then. I know the time is wrong, but again, we didn't set the clock. Return code. That's statistics. I don't see nothing about no return code over here. Correct me if I'm wrong. If y'all see anything about a return code, I don't see anything there. What's the number of successes and failures? We got 2 successes and 1 failure. Basically, remember we said we're going to ping. This guy is going to ping him every 90 seconds. I've been talking y'all ear off for about 3 minutes now. So that's about 2 pings, right? If we refresh and see again, that's about 2 pings still. Maybe if we do it again, we'll see another ping. But anyways, no failures. So basically it's working. Operation time to live, forever. Good. On router 0, shut down. So on not router 0, router 1, shut down the serial 00 interface. So now we're going to go to user exec mode, global config mode, and he said to go to interface serial 0/0 and shut that interface down. We shut it down. After waiting approximately 90 seconds, display statistics about the IPSLAs configured on router 3. What differences do you notice about the start time, return code, number of successes and failures? So we're going to go back to router 3, run that same statistics command. Take a look at this, and you'll see EIGRP went down, right? Now, also, take a look at these statistics. You want to pause it, freeze frame it, and compare it? All right, we back. Let's go ahead and do a show IPSLA statistics and take a look at it again. Now we have a failure. We notice the return code is also timed out. Latest round trip time, no connection, busy, or timeout. So that is the differences there. So basically our SLA is failing, but we didn't set an action for it. We just said, hey, just check the status of this interface over here, 10.10.10.1. We didn't say what to do with it afterwards. So on router 1, re-enable the 000 interface. So we're going to go back to router 1, do a no shut. It's back. EIGRP is back up. We go back to router 3, run that command again, and you'll see we'll have to wait 90 seconds for us to get another success here. And I don't want to waste y'all time here. So, all right, task 2, redirect telnet traffic from router 1 to router 1 from router 3's LAN. So we're going to redirect our telnet traffic from this local area network. We're going to have telnet traffic to router 1. I believe it normally takes this way. We're going to change it so that way. If we have specific, like if it says, if we get traffic from somewhere in this local area network, take this way. We're going to create an ACL to do all of that, right? So in this task, we will configure PBR on router 3 so that telnet traffic sent to router 1's loopback 0 interface right over here to router 3 is automatically forwarded over to WAN link instead of the faster Ethernet link, which is this way. So we're going to have it take the WAN link instead of this link to router 2. All configuration steps will be performed in router 3 unless otherwise. This is the password. So let's go ahead and do that. We'll go back to router 3. Step 1, create an ACL named PBR telnet. Well, we know that is a CCNA fundamental. Plus, we do a little bit of that in our CCNP studies. We go to global config mode. And we know to start an access list, we do IP access list. He said he wanted an extended one. We are going to name it PBR-telnet, all caps. Context sensitive help says to do the chars return. That means we just press enter. Now we are in extended ACL configuration mode. Step 2, configure the ACL now named PBR telnet to match telnet traffic from any source to any destination. All right, so we are going to configure the ACL to match telnet. So we know we want to do the keyword match there tells us we need to do a permit. He said telnet traffic. So we do a context sensitive help. Do you see telnet in here? No, it's not. But we do know telnet is TCP traffic. So we're just going to do TCP. My bad. TCP. He said from any source to any destination. That tells us any. What else did he want? He said telnet traffic. So that means we need to match packets on a given port number. What's the port number for telnet? I'm not going to do a pop quiz because that's an easy one, right? EQ. So we're going to see EQ, telnet. Matter of fact, yeah, I'll give you, that's your other pop quiz. That's your other pop quiz for today. What is the port number for telnet? And we're not going to log any entries. We'll just push enter here. That's y'all second pop quiz. Y'all got bonus, 2 pop quizzes, right? Step 3, create a route map named PBR that will permit traffic and has a sequence number of 10. Well, let's go ahead and get out of this. Go back to global config mode and he said a route map. So that means we know it's route-map. He wants us to name it PBR with a sequence number of 10. Permit traffic. So we said route map PBR, all caps, my bad. And he said he wants us to what? Permit traffic with a sequence number of 10. That's pretty much it right there, right? Configure the route map named PBR to permit IP addresses that are identified by the ACL named PBR telnet. What other types of identifiers could you, let's go ahead and just do this part right here and then we'll go to the question. So we got to configure this route map to permit IP addresses. So we know that, remember, route maps, I said this in the route map video. Once you're in the route map config mode, you do something that's a match and then a set. We're going to say match this IP address or match whatever this is. If you match that, set this as the action. So remember, match, set. Sound like a broken record, but that's how I remember route maps. Those keywords, match this, set it to that after that, right? So we know we got to do match. We could do set, but that's how I remember it first. So match values. What do we want to match? He said we want to match IP addresses that are identified by the ACL now named PBR telnet. So if we do a question mark here, what do we want to match? Well, we don't see an ACL here, but we do see IP. Next hop? No, we don't know. We don't, route source? No. Address sounds like it, so we'll do address. Match IP address that is in the access list, right? We said access list, so we can put the number of the access list or the word. Obviously, we have an access list named PBR-telnet, so we're going to do PBR-telnet. So we're basically saying match any IP address in this ACL, right? I know sometimes ACLs, like when I was studying for CCNA, access control lists was kind of tricky for me. But now we're combining access control lists with route maps. But, you know, if you just break down the syntax and even question mark through it, some of the simulators on the exams allows you to question mark, and it'll kind of give you a clue on what you need to do next, right? Right here, we have the ACL. What else we need to do so far? We don't need to do a number here. We're just going to say match the IP address of this ACL. Anything else? We don't need to do access list number. We'll just hit enter here. What type of identifiers could you configure? Well, we could do an ACL by number or name. There's other identifiers. I really don't know. Step 5, configure the route map named PBR to use router 1's serial 00 interface as the next hop for traffic that is matched by the ACL named PBR telnet. So what we're going to do here is we're still in the route map mode, config mode, right? Now we can do the set. So what do we want to set? Well, we want to set default, no. IP, maybe. Metric type, tag? No. We know it's either interface or IP. Well, we said, well, we do have an IP. That's more specific. So let's go with IP. Set the IP. Next hop, he did say this IP address is the next hop. So IP next hop. What's the IP address? 10.10.10.1. We question mark through that. Set the next hop as 10. So basically we're saying if you get any telnet traffic that comes through this interface over here, set its next hop to be 10.10.10.1. That's basically what we're doing with this route map here. Y'all get it? So we press enter here. So now, before we move to step 6, let's go ahead and check our route map here, right? We'll do show IP. We'll just do show route hyphen map. We got a match clause. Match anything in this access control list. If you match that access control list, set its next hop to that. That's basically what we're doing here. So far we have no matches here, right? 0 packets, 0 bytes. Step 6, from PC1, which is located here, telnet to router 1's loopback 0 interface, quad 1, then quit the telnet section. So we're going to telnet from PC1. Theoretically, it should go that way, and then quit the telnet session. So we're going to telnet 1.1.1.1. I hope y'all know how to telnet. Capital B0S0N was the password. We press enter, and we're telnetted to router 1. Right? So we went from here and telnetted to router 1. Then he said to quit the telnet session. Right? So we're going to go ahead and exit out of this. Step 7 says on router 3, verify the configuration of the route map. We did that already by displaying the route map information. Has the policy matched any traffic? If not, why? So we're going to go back to router 3, run that same route map command. I guess I skipped ahead. And if you notice, we said match telnet traffic, set the next hop to this. No, we didn't get any matches. Y'all know why? Pause it and think about it. PC1 basically went through his regular way, which is going through here. Well, you know what? We didn't apply the route map to the interface. So that is why. Step 8, access router 3's Ethernet 01 interface and apply the route map named PBR to that interface. So we're going to go to router 3. We are on him, and then go to global config mode. And we're going to say interface Ethernet 0/1. And he said to apply the route map. Y'all know how to do that? I believe it's just IP policy. I know it's tricky. You would think it'd be like route map and then whatever, right? No, it's IP policy and then route map. And then the name of the route map, which was PBR, right? Hyphen or capital PBR, right? We could also verify that with just the show IP interface Ethernet 0/1. Sorry for yelling at y'all with the caps right there. And we can see, where's our policy here? Let's do a show IP. Let's do a show route hyphen map. And there's our route map again. Now he says from PC1, telnet to quad 1 and then quit the session again. So now we're going to PC1 is going to telnet that way, or telnet to router 1 again. So we got to go to PC1, run that telnet command again. Password was B0S0N. Now we're telnetting in router 1. Let's exit out of this. On router 3, display route map information. So I'm going to go back to router 3. We're going to run that route map command again, that show command, show route hyphen map. And now if you notice, he says here, is telnet traffic being forwarded based on the route map? How many packets and bytes have been redirected over the WAN by the route map? Well, it looks here we do have a match because if you notice, 5 packets were matched and we have 390 bytes. So yes, our route map did work. From PC1, trace the path to router 1's loopback interface, quad 1. What path does ICMP traffic take from the LAN to router 1's loopback 0 interface? Why? So we do a trace route from PC1. We're going to do trace route to quad 1. Oh, my bad. It's like a PC trace RT 1.1.1.1. And you notice took 3 hops to get there. Now that's weird. You would think, oh, you know why it took 3 hops? Because we're not doing telnet. That's why. So when he telnets, he's going to take that way. But when he's just sending ping packets or trace route, he's going this way. That's basically why. Task 3, test connectivity before forwarding telnet traffic. In this task, you will configure router 3 to verify connectivity with between router 3 and router 1. So we're going to test connectivity on router 1's serial 00 interface, which is located here. IP address quad 10 or 1 prior to sending telnet traffic. So basically, we're going to test connectivity on this interface before we send telnet traffic, right? That interface before you send telnet traffic. You'll also configure a second next hop for the router to use telnet traffic in case router 1's 000 interface becomes unavailable. With that, we know the password as the VTY line on router 1. On router 1, shut down the serial 00 interface. So we're going to go router 1, go to user exec mode, go to global config mode. We're going to say interface serial 0/0, was it? He said to shut it down. We shut it down. From PC1, telnet to router 1's loopback 00 interface. Does the telnet succeed? Why or why not? Probably not, right? So we're going to go to PC1. Come on, this mouse tripping, man. We're going to telnet. No, did he say telnet? He said destination unreachable. Why is it unreachable? Well, because we take serial 00 and it's shut down right now. So he's not using this interface to get there. He's using that one. We have an access control list to go that way. And a route map, really. That's why. On router 3, create a tracking object with an ID of 1. Now, this is what we came to do. I know y'all waited about 20 minutes before we did some tracking objects. But this was a review of IPSLA along with route maps. So we're going to create a tracking object with an ID of 1. We said, how do we do that? We say track object, and then we can do whatever we want from here. So it's track object, and we can track the interface or whatever. We can do a static route, but we're going to be doing track object and then probably an interface in this case. So he said track object with an ID of 1. So we're going to go to router 3, go to global config mode. Did he say to bring that serial interface back up yet? No, he didn't. We're going to create a track object with this track. He said ID of 1. We said configure it to track the status of IPSLA 1. Okay. Is it an interface? No. Is it IP? Yeah, probably. So we're going to say IP. We question mark, we'll see SLA, right? You'll get way more options than this in the real iOS. Which SLA? Well, we created SLA 1 in the beginning of this lab. What else we want to do? That's it. Carriage return. We press enter. So now we're tracking an object called track 1. What is going to be the tracked object? The service level agreement, which is operation ID number 1. That's what we're doing there. On router 3, access sequence number 10 of the route map named PBR. So now we need to go back to route map config mode for sequence number 10, which is this route-map. And the route map was PBR permit, right? And it was sequence number 10. Now we're in route map config mode. He said remove the next hop IP address that was previously configured. Well, we can do that with just a no, I believe, not IP next hop. No, let me see. What's our options here? No, I believe it was the set. No, yeah, because we set the next hop, right? I can't remember. Let's do a show run to verify that. Let's do a show run to verify what was the next hop. I believe it's set. So yeah, we need to remove this right here, basically. Remove that next hop, which was, yeah, so no set IP next hop, right? No set IP next hop. We can just do that to get rid of it, right? And then he says on router 3, configure the route map to use tracking object 1 to verify connectivity prior to using router 1 serial 00 interface. This is a tricky one, right? So we need to configure the route map to use tracking object 1. So let's do a set We know that's going to be a set. Let's see. Do we want to set an interface, an IP address? Yes, we want to set an IP address. But we also want to set an interface. That interface is not on here, so we're going to say, if we set interface, right? Yeah, we don't want to do set interface. So we might want to do a set IP, but we want to configure the route map to use tracking object 1. That's what we want to do. This is the tricky one right here. Set next hop, maybe quad 10. Yeah, verify availability. We want to verify it first. That is the tracking object. That is how you do it. Verify availability, right? So next hop, verify availability, verify hyphen availability. I'll type in the entire thing since that's what it wants me to do. What's the next thing to do? Default next hop, IP address, which will be 10.10.1. So we'll do 10.10.10.1. What's the next thing they want us to do? Sequence to insert into the next hop list. Believe we're going to do 10. Right? Did he say that? He didn't really say. Let's check the answers real quick. I'm gonna be transparent with y'all. So let's go ahead and do that. Task 3, question 6. We only got 2 more steps until we're done here. Task 3, that's what it is here. So we want to set. He didn't really say what sequence number here. So we're going to just so we was almost there. After the IP address, we need to set the insert into the next hop list. So the sequence, basically, he didn't really tell us what sequence, basically. So we're just going to do 1 here. After that, you do track, and then what's the track object number. So that's kind of tricky. I guess they just didn't tell us what sequence number there. Sometimes they just not going to tell you step by step what to do here. So we'll go, that was step 6, right? So we press enter here, right? No, what was the track? Track 1. After that, that's it. We press enter here. Step 7, from PC1, telnet to router 1's loopback 0 interface, quad 1. So we go to PC1, telnet again. What's the password? Capital B, 0S0N. Right? Then he says to go ahead. Does the telnet attempt succeed? If not, why not? It did succeed. Why did it succeed? Well, because even though that serial interface is shut down, basically we created a route map that is going to track the object. It said if this interface is down, use the route map to go this way, and then we'll still reach it. So that's how come now we're able to reach it. So now if we do, we can go to enable mode, and we're in enable mode. So we can get out of this. Exit the session. Step 8 says on router 1, re-enable the 0.0 interface, and he doesn't want us to do anything else after that. And you can see it'll probably take that way again. So we go to router 1, go to privileged exec mode, global config mode. We'll do a go to interface serial 0/0, re-enable it, no shut. And they didn't really want us to do anything else after that. But obviously, now that there's no shut, we can telnet back to this way again. That is all I got for y'all today. I know this lab was maybe a little bit confusing for some of y'all. It was a little bit for me too, but I realized once I question marked my way through it, it helped me break down the syntax a little bit more to figure out what's going on, because in this lab, we combined the topics of IPSLA, we did some route maps, and we also did track objects. So we combined all of those theories into one lab. And that's what's tricky about it. That's why I love Boston NetSim as well. Anyways, that is my YouTube page. That is my Twitter handle. Go ahead and add me on Twitter. Please comment on this video. Let me know what I can do to better explain this, or make this a little bit more fun. Please share these videos on your social network. I've been noticing, man, people have been shouting me out, and I really appreciate that. Shout out to user, a subscriber, Clark Bragay. I don't know if I'm pronouncing your name right, but I went on to Reddit and I realized people was recommending my channel, so this is pretty dope. When you see your YouTube channel and your following that's growing. So shout out to Clark. Also, subscribe to my channel if you haven't yet, man, because some of this stuff can be a little bit boring, but I show you that anybody can do this stuff. If I can do it, y'all can do it. And again, this is my journey on trying to achieve my CCNP certification. And I hope you guys are having fun. And, don't use this as your only source of, studying. Use this as supplemental learning. So make sure you are labbing every day. Make sure you're doing some reading. And make sure you get some of this stuff hands-on. For now, please comment, like, subscribe to the network.